We're continuing with these 3D particle equilibrium problems. This is another good exam problem. It's very similar to this first one we did. This first one, we gave you a vector in terms of spherical coordinates, and you had to know how to resolve that into x, y, and z components. This one, I give you this vector in terms of coordinate direction angles, which are the angles from the force to the x-axis, to the y-axis, and to the z-axis. And so TC as a vector is equal to 238.4, and the unit vector terms are cosine 70.5, cosine 25, and cosine 75. And remember, these are called direction cosines as well. And these are the numbers of these. You can actually put these into your calculator. You can do these separately, or in your calculator, you can, it's kind of cool how this works. You can go control vector, and then you can put trig cosine 70.5, comma, trig cosine 25, comma, trig cosine 75. Step out, enter. And that gives you this 0.3338, 0.9063, 0.2588 already as a vector. And then you can take that vector times 238.4, and that gives you the actual force components themselves: 79.6, 216.1, and 61.7 pounds for TC. So again, having the TI-89 or the Inspire really help on these guys. So that gives you TC completely. Once you have TC, the exam problem might say find TA, or it might say find TB. And so to find either one of these, it's just a single equation. For example, if I sum forces in the x direction, TA does not have an x component, but TB does. So I basically sum force in the x direction. I have 79.6 minus 4/5 of TB is equal to 0. And so TB is 99.5 pounds. Or the problem might ask you to find TA. And so to find TA, you sum forces in the y direction. And the y component of TC is 216.1 minus TA cosine of 20. TB does not have a y component, and so you can solve for TA is 230. So either one of these is a fair and reasonable exam problem, just relatively straightforward. You need to know how to deal with direction cosines, and you don't really need the whole vector. I mean, we could have, if all we needed was the y component, we could have said 238.4 cosine 25 is the y component, minus TA cosine 20. And that would have been our y equation. Or in the x direction, we could have said 238.4 cosine 70.5 minus 4/5 of TB to get TB. So we didn't have to write the whole vector here necessarily. So, but this is a good exam style 3D particle equilibrium problem. And again, we're writing the equilibrium equations, sum forces x and y, z is equal to 0. This is the same problem as a 3x3. So just for completeness, this is the exact same problem, but I didn't give you TC in this case. So it works the same as our previous problem. I've got three unknowns, TA, TB, and TC. I've given the directions of all three. And so I can write the unit vector for TC, the unit vector for TA, the unit vector for TB, and the unit vector for the weight. The unit vector for the weight is 0, 0, minus 1 times 200. I can evaluate all of these guys to get these terms. And again, my vector for my weight is 0, 0, minus 200. If you write it out this way, then this column are the terms in my x equation. This column are the terms in my y equation, and this column are the terms in my z equation. So in the x, I've got 0.3338 TC, 0 TA, negative 0.8 TB is equal to 0. My y equation, I've got 0.9063 TC, negative 0.9397 TA, 0 TB is equal to 0. Z, got 0.2588 TC, plus 0.342 TA, plus 0.6 TB, minus 200 is equal to 0. This guy leads me directly to the matrix form. And so all of these components are my coefficient matrix, exactly as is. And the minus 200 goes to the right-hand side. And so my vector of constants is 0, 0, 200. I won't show you how to do this in the calculator, but you can. Just use the simult function. Use the template to get a 3 by 3, comma. Use the template to get a 3 row column. And plug in these guys in here, plug these guys in here, and you get the answers, which are TC is 238.4, TA is 229.9, and TB is 99.5. And that's where this guy came from. I gave you TC was 238.4, and this is 238.4. So it's the same problem, but solving a full 3 by 3 is not going to work on an exam. But giving you that guy and asking you to find one of these other two makes for a workable problem. You should be able to do it all, but and get good at your calculator. That will certainly help you.